Hello learners and welcome to your natural sciences lesson. So today we're going to be dealing with practice questions and application questions that are based on resistors. So starting with our practice questions, the first question says, what type of materials are normally good conductors of electricity and how is electricity conducted in these materials? So we know that we have good conductors of electricity, we have conductors, we have insulators, and then we have semiconductors of electricity. Now, the good ones, those are the metals. So metals, they are the good conductors of electricity. We can also even give examples if you want. We can say, for an example, pure silver, let's just give two, pure silver, gold. Those are good conductors of electricity. So question now is, how is electricity conducted in these materials that we are saying are good conductors? So what we know is, it is conducted through the delocalized electrons. On the outer layer of the metal. So it is conducted through the delocalized electrons that you find on the outer layer of the metal. Remember, we have electrons on every metal, but then the ones that are on the outer layer, they are free to move around however and wherever they want. So the moment we start connecting a battery to that wire or to that metal, then those electrons will start now to move from the negative terminal to the positive terminal, and that movement is going to be generating our electricity or our electric current, as the question is asking. Then question 2, what type of materials are normally insulators or non-conductors of electricity? So what type of materials are normally insulators or non-conductors of electricity? So those are the substances, or those are the materials that do not have the free delocalized electrons on the outer shell. So we can talk, for instance, say plastic. Plastic is an insulator because it doesn't conduct electric current. Now, what is the reason for this? So basically plastic, or we can just say non-metals. Remember, when you're talking about non-metals, we need to be specific to say except for carbon, because carbon is not a non-metal, but carbon in a form of graphite can be able to conduct electricity. So non-metals except for carbon. Now, what is the reason for this? Because the outer electrons are tightly bound to the nucleus of the atom. To the nuclei of the atom. And because of that, they are unable to move of the atom and can't move freely. So the outer electrons that are tightly bound to the nuclei of the atom, they can't be able to move freely, because remember, it's the movement of those electrons that generates the electricity. So because these ones are not able to move, therefore they can't generate electricity. Then question 3 is asking us, what is the purpose of resistors in circuits? We use resistors to regulate or we can say to control the current strength. So we are using the resistors in a circuit to control or to regulate the current strength. So to regulate or to control the current strength in a circuit. There we go. Now moving on to the next question, question 4. What is the use of conductors with a high resistance? So now, why do we use conductors with a high resistance? Remember, we use those particular conductors because they can generate heat and light. So we are using the conductors with a high resistance because they can generate heat and or light. Remember, the resistance between the conductor and the flow of current is going to generate the heat. And if the conductor has a high resistance, that means the heat that is going to be generated there is going to be high. So we are using those conductors with high resistance because our main idea is we want to generate the heat. Now, what is then the disadvantage of resistance in conductor? So the resistance in conductors, what is it? It limits the flow of current. It also generates heat, and that heat is lost, or we can say it is wasted as energy. So the energy that we want will not be the energy that we get, because some of the energy is going to be lost or wasted. So some of this energy is going to be lost or wasted in a form of heat when there is that resistance between the conductor and that particular flow of current as it is moving from one point to the other. Now, question 6 wants us to describe the following terms. Term number 1, what is an electrical conductor? So we need to know what an electrical conductor is. And that is now substance or a material that allows, remember keyword, it allows electricity to flow through it. Why? Because it is a conductor. It allows electricity to flow through it. Then the second one is an electrical resistance. Remember, resistance. Now that is now a measure of the opposition to the current flow in an electrical circuit. So when we are measuring the opposition of the current flow in an electrical circuit, that's what we call an electrical resistance. Then the next term that we need to describe is electrical insulator. Remember, we have conductors, we have non-conductors, which are sometimes referred to as insulators, and then we have semiconductors. So there are different types of these materials that we have. If a conductor allows electricity to flow through it, then an insulator, that's now a substance or material in which electric current does not flow. So this particular substance or this particular material doesn't allow any electric current to flow through it because it is a non-conductor or because it's an insulator. So now, and then the last word that we need to describe is resistor. So a resistor is, that's an electrical component that creates resistance in the flow of electric current. So it's a component that creates resistance. So basically, it doesn't want the current to flow through a resistor. Remember that a resistor has resistance. right? So there's a difference between a resistor and resistance. A resistor contains resistance, and that is now what is going to inhibit, or the one that is going to fight against the flow of current because it doesn't want the current to pass through it. Right, so those are the words that we are required to describe, and we have described them. I hope now you know what each of those words mean. If you are asked in an exam or a test, you can be able to answer and describe all of these words that you are given here. So now, before we move on, we're just going to go for a quick short break, and I will see you just after this.